Dear students, now we are going to discuss the subject of antenna design. The subject code is CEC 335. So now we are going to discuss the unit 1. So see here the syllabus consists of four parts. The first part is linear array. It contains two element and uniform n element array. And the second part is array weighting. In that we are going to discuss about beam steered array and weighted array. And the third part we are going to discuss about circular arrays and rectangular planar arrays. And the fourth part we are going to discuss about fixed beam arrays, Butler arrays and fixed side lobe cancelling. And the fifth part we are going to discuss about retrodirective array. In that we are going to discuss the two types of retrodirective array, passive and active retrodirective array. So the first topic we are going to discuss about linear arrays in antenna design. So what is linear array means? The linear array is the simplest geometric arrangement where multiple identical antenna elements are aligned along a straight line. So if you want to make the antenna design in the format of linear array, you have to keep that antenna elements in the straight line with the element spacing d. So these are the arrays used to achieve high directivity and gain, allowing for more efficient long distance communication than a single antenna element could provide. So that linear array arrangement is, so you need to keep multiple antenna elements in the straight line axis. So now see here this diagram. So you are keeping here the antenna elements 4. So you are taking the example for antenna array 4 elements. So now you are keeping these 4 antenna elements in the straight line with that spacing d. So here see that ray, the first ray 1, ray 2, ray 3, ray 4. So each consists of that antenna spacing is d and the angle formation is theta. So here the array factor is d cos theta. So now the next thing, see here, if you want to keep n element antenna arrays also, you can achieve using of this linear array. See here, you are keeping number of n element antenna element with equal spacing. So like that, you can increase the number of antenna element in any sizes, and you can keep this antenna spacing also based on your application. You can keep equal or non-uniform. So if you are keeping the antenna element with equal spacing, that type is called as uniform linear array. If that antenna spacing is unequal means we call it as non-uniform linear array. So the antenna spacing is equal means we call it as uniform linear array. If that antenna spacing is not equal, we are call it as non-uniform linear array. So here the array factor is formed based on d cos theta. Now see here, this is the arrangement of linear array. So here we are using the phase shifter, no? That using of this phase shifter only you are applying the theta value, and the spacing element is d. So here we are using the splitter or combiner, and based on that we are doing the radiation pattern. So this is the real time setup of linear array. So now see here, this is the practical examples of linear array, how they are keeping. So now see here the linear array. So this is the real-time space of arrangement of antenna elements. So you can keep that n element antennas with equal spacing, and you can check the straight line axis if you are keeping antenna element. What is the performance of your system? So this is another example of this linear array. So now in that linear array, we are going to discuss the core design principle. The three main important core design principles are there. The first thing is pattern multiplication, second thing is inter-element spacing, third thing is array factor. So the pattern multiplication, you need to multiply the product of element factor and array factor. So what is element factor means the pattern of the single antenna. So what is array factor means the pattern resulting from the geometric arrangement and the relative phasing. So here the diagram we are discussing no d cos theta. So that is the array factor. So that element factor is nothing but, so based on the types of antenna, we have different element factor. So you have to product this two factor, element factor and array factor. And the second thing is inter-element spacing. So typically you have to set off wavelength to maximize the directivity while avoiding the grating lobes. So because that undesired secondary beams that will be waste the power. And the third main important principle is array factor. So this factor is depend on the number of elements that spacing and the electrical phase difference between them. So it determine the properties like beam width and the ability to electronically steering the means. So these are the three main core design principles. And here the linear array, there are four common configuration. The first thing is broadside array. So here we need to that elements are fed in the phase beta value is 0. That will be resulting in the maximum radiation perpendicular to the array axis. So the value, the phase value beta value is 0 means that configuration we called it as broadside array. And the second thing is end fire array. So here the elements are fed with the progressive phase shift, directing the maximum radiation along the axis of the array. And the third thing is phase array. Here the scanning array where the phase shifters are used to electronically steer the beam in the any arbitrary direction without physically moving the antenna. And fourth type is collinear array. So here the elements are arranged in the single line, one after the another, commonly used for high gain omnidirectional broadcasting. So what are the application of this linear array? So in recent days we are using for 5G and next generation networks. So here the linear arrays enable beamforming and massive MAMO, which are essential for managing the high path loss of millimeter wave frequencies. The next thing is automatic radar. So the high gain linear arrays is autonomous and semi-autonomous vehicle system. And the third main application is satellite and deep space application. So the linear arrays are used in mobile satcom terminals and ground station to track satellites without mechanical movement, ensuring stable links even in remote or undeserved areas. Thank you.